So for our next example, we want to verify that cosine of alpha minus beta over cosine of alpha times cosine of beta is equal to 1 plus tangent of alpha times tangent of beta. So this is more like what we saw in 5.1, but we've got different pieces that we're going to play around with because we've got more identities to work with. And in particular, we have things to work with in terms of differences of angles, specifically like what we see on the left side. So besides the fact that the left side looks more complicated, we've done a lot of manipulations on left sides to begin with, and also we don't have anything in terms of products of tangents yet. Well, we've got a new tool that can help us with that cosine of alpha minus beta, so why not use it? So, on that left side, what we're going to do is take that cosine of alpha minus beta and split that up into cosine alpha, cosine beta, and sine alpha, sine beta, where we can then take that rational and split it. Splitting rationals is something you're going to see when you get to Calc 2 for a specific integration technique. And once you split that rational into cosine alpha, cosine beta over cosine alpha, cosine beta, plus sine alpha, sine beta over cosine alpha, cosine beta, and there's a lot of Greek letters here, you'll see that that first term just simplifies down to 1, while the second term, you can split that up into sine alpha over cosine beta and sine alpha over cosine alpha and sine beta over cosine beta. I'm going to match those terms, and it's not very useful. But because they're the same angles, and it's sine over cosine, we can just split that into a product of tangents. So we get 1 plus tangent alpha, tangent beta, as we hoped. Pretty straightforward. And next we're going to see an example where we can do this. Same idea, but we're going to look at it in more of a mixed context. We've got some information about the locations of angles and how we can turn that into expressions for sums and differences.